this video, we're going to be talking about friction and the factors that affect it and how we can calculate it. And friction always opposes motion. So if something's moving to the right, friction is going to be a force that's pushing it back towards the left. The factors affecting friction are the types of surfaces. Okay, some things are kind of sticky, like sandpaper would give you a lot of friction. Ice would give you very little friction. We can measure how sticky they are by finding their coefficient of friction. And the symbol for it is the Greek letter mu. And it's a measure of stickiness of surfaces. So ice would have a very low coefficient of friction, and that sandpaper would have a higher one. And the second thing is the normal force. If I try to push something across the floor, it will be kind of difficult, but if I push down on it as I'm trying to slide, it'd be even harder. So greater normal force will give me greater force of friction. And when we put this together, we come up with this equation, Ff equals mu, the coefficient of friction, times the normal force, F. So here's an example. Coefficient of friction between a block and a table is 0.3, so this is our coefficient of friction. And it's being pulled across with a force of 12 newtons, and we're going to know the acceleration. So we draw a free-body diagram. Label this as a 2 kilogram mass. It has a force of 12 newtons forward. There's gravity acting on it. Fg equals G. 2 times 10. So the force of gravity on it is 20 newtons. There's no other forces up or down on it, so there has to be a normal force of 20 up to balance it because it's not moving up or down. And then we have the force of friction back this way. Now with that new equation, we can calculate the force of friction. F is mu Fn. So the mu is 0.3, Fn is 20, and that gives us a force of friction of 6 newtons. So, now we can do our off-net equation. I have 12 pulling forward, and 6 for friction pulling back, equals the mass is 2 times A. So this means 6 equals 2A, so A is going to be 3 meters per second squared. Now we're going to talk about the degree of static and kinetic friction. The definition of static is that it's not moving. And static friction is greater than. And then kinetic is what it is. So for any surfaces, you'll have kinetic coefficient of friction, static coefficient of friction, and the static coefficient of friction will be larger. The reason why is I think of a couch that's kind of sunk down into a carpet. It's harder to get it moving, but once it's moving, it's easier to push it along. So it's harder to start something. It's harder to overcome the static friction than it is to keep it moving and overcome the kinetic friction. The equation changes slightly for the static. Instead of being Ff is mu Fn, now it's going to be Ff is less than or equal to mu Fn. But for kinetic, it's the same. And here's an example where you see that. Coefficient of friction between a 20 Newton block and a table are static here is kinetic here. And we want the force necessarily start the 20 Newton block in motion on the table. So for part A, we'll draw our free body diagram. gave you this a 20 Newton box, so I'm not giving you mass this time. I'm giving you the force of gravity on it. So the force of gravity is 20 newtons. We can work backward, and that would give us a mass of 2 kilograms. My normal force is 50 newtons. Now, I'm going to have a forward force this way, and a force of friction like that. Now, in order, when it says to just start it, okay, when you see the words to start, you have to overcome static friction. So we're going to use the static one in this case. So F is less than or equal to USFN. F is less than or equal to the static coefficient, which right here was 0.4. Our Fn was 20. So F is going to be less than or equal to 8 newtons. So that's going to be our answer. Now, if F equals 8 newtons, we block this line. So if I tried pulling with a force of 5, like it says here in part B, what's going to happen? Well, we know it's not going to move. So we have 2 kilograms. We have F. G is 20 newtons. Fn is 20 newtons. Pulling it this way, a force of 5 newtons. Now we know, we figured out back here, that it has to be at least 8 to make it slide. So what's the force of friction going to be? Now it turns out it's not going to be 8, okay, because of that less than or equal thing in there. If this is not going to move, this force forward and the friction have to cancel. So the force will be 5. So whatever force I pull forward with, as long as it's not moving, the force of friction will be the same. So if I pull it forward with a force of 2, the force of friction will be 2. However, once I get to 8 or above, then it will start to slide, and they won't be. And then part C, what force is necessary to keep it moving at a constant speed? So now we're moving. So if I draw my 3-body diagram again, I have 2 kilograms, forward force. The force of gravity is 20 newtons. Fn is 20 newtons. I'm going to have that back this way. Now, since it's moving, I have to use the kinetic one. And the kinetic friction was 0.25. And Fn was 20. So that's going to give me a force of friction of 5 newtons. Now, it's going to be constant speed. That means the forces cancel. Therefore, the forward force has to equal the force of friction. The forward force is 5 newtons. One more example on the next page, and this is as involved as I can make it. We have a block being pulled forward by an 18 newton force, but this time at an angle of 30 degrees, and we want to find the acceleration. So I'm going to draw a little 3-body diagram. I'll draw it right on here. We have Fg is going to be 20 newtons. Fn. Now we have to be careful. It's not going to be 20 newtons this time because this 18 newtons is pulling up on it a little bit. So I have another up force. Then I'm going to have the force of friction back here. Now, whenever I have one of these things at an angle, I'll split the forces up into their x and y components. So F of x is going to be 18 cos 30 divided 15.6. F y is 18 sine 30, which is 9. I'll write these right on here. So this is 15.6. And this is 9. Now we can figure out the Fn, okay? Because of our y forces canceling, it's not going to be moving up or down, just to the left and the right. I can say that my up forces, Fn plus Fy, have to balance my down force was Fg. So Fn plus 9 is one is going to be F is 11 newtons. Now we can figure out our FF. Mu Fn. FF equals mu from this is 4. Fn is 11. That's going to be 4.4 newtons. Got to finish out the problem. We do an F net equation. And I just never worry about my X portion now. I have 15.6 going to the right. It's a force of friction of 4.4 going back the other way, so I'm going to subtract it. Then I end up with 11.2 equals 2a, and then our acceleration, 5.6 meters per second squared.